Are you thinking of installing a ductless mini split? I'll show you how I did it coming up. Welcome to episode 4 of The Average Craftsman. My name is Tim, and on this channel I do woodworking and DIY projects, so if you're into that sort of thing, please consider subscribing. In today's video, I'm going to show you how I installed this 18,000 BTU 20.8 SEER 1.21 gigawatt Pioneer ductless mini split. There's a lot of options out there to heat and cool a garage workshop. In the description down below, I have a link to my website which has a detailed install article for this project. In that article, I walk you through the steps that I took and the research that I did that led me to ultimately decide to go with a ductless mini split to heat and cool my 500 square foot garage workshop. Before we get started, let's get something out in the open. I am not an electrician. I am not an HVAC technician. I am not an expert on electricity or heating, ventilation, and air conditioning. This video is simply showing what I did that worked with my specific situation, my local codes, and my knowledge. If this is something you feel like you can tackle yourself, that's great, but please consult a professional before doing any electrical or HVAC work. All right, let's get to the install.
I ordered my unit on a Tuesday and it was delivered via freight about a week later. While these units aren't massive nor too heavy for one person to move, they are shipped via freight rather than by standard FedEx or UPS. Shipping via freight can be a roll of the dice sometimes, but this unit was well packed and apparently handled with care. I started out by unpacking everything and comparing it to the installation manual to make sure nothing was left out. There's all kinds of accessories you can order for these mini splits. I ordered a line set cover and a wall mount bracket. After looking at how the bracket was going to install to my house, I decided against it and will be sending it back and just mounting the unit on the ground. Once I went through all of the accessories, I opened up the box containing the indoor unit and laid it out on my assembly table. I then removed the mounting plate from its shipping location on the back of the indoor unit. The first step in installation is to mount the indoor unit. I debated on a few different locations in my shop and settled on placing it high on the wall between the door and the window. I picked this location because it is good for airflow and it is also the most convenient for the line set and electrical runs. To make room for the indoor unit, I had to remove this top row of tool storage. I then moved on to marking out the location of the unit so I could attach the mounting plate. The manual specified the clearances required for the unit and also provided a drawing of the mounting plate in relation to the unit, which made locating the plate very easy. According to my research on mini splits, ensuring that you account for all the clearances around the unit is imperative to proper functioning of the unit. Having plywood walls in my shop made attaching the mounting plate very easy. I ran a screw in the middle of the plate and then made sure it was level and ran screws in a few more places. With the mounting plate attached, I did a test fitting of the unit just to make sure everything went okay, and then I moved on to marking out the location of the hole to be drilled for the line set to be run through. This unit allows for the line set to be run out either the left or the right side of the unit, or it can be run straight down from the unit along the wall. When you're drilling this hole, it's important that there is a slight angle downward out of the house. So what I did is I took a very long drill bit and got a pilot hole started through there, and then came back with a 2.5 inch hole saw and drilled through the inside of the house, and then went outside using that pilot hole and drilled through the outside of the house. With the line set hole cut, I placed the sleeve on the inside and then started to mount the line set covers on the outside of the house. Before I could mount the indoor unit, I had to connect the signal wire. I removed a panel from the back of the unit and then flipped it over so I could access the wiring terminals. To access the wiring terminals, I removed this cover and then also had to remove a cable clamp. I could now run the signal wire through the back and into the front of the unit where the wiring terminals are located. I didn't have a way to get a shot of wiring this up, so here's a picture that shows how the wires are connected. The wiring terminals are not labeled anything other than 1, 2, 3, and ground. Based on the few units I've looked at, this is pretty common. It's imperative that you remember which color is connected to which number, because the terminal in the outdoor unit is exactly the same, and if you switch anything around, at best your unit won't function, and at worst you'll ruin your unit. The signal cable contained black, red, white, and green wires, and since green is commonly used for ground, I connected that to the grounding terminal. For the other three, I just went black 1, red 2, white 3. After everything was connected, I made sure to grab a picture with my cell phone so I could reference that later when I was connecting the signal cable to the outdoor unit. Once the wiring of the indoor unit was complete, I sealed up the front and back and for the time being set it aside. At this point, I decided to turn my attention to running all of the electrical for the system.
I now need to get power to the outside unit. I'll go up from the sub panel, across the ceiling, over to the wall, out the wall, and then down on the outside of the house. This will all be running in 1/2 inch EMT conduit. Where it goes to the wall, we have a galvanized L, which screws into this galvanized nipple. Like so, and then has this galvanized connector, screws on like this, and then I can take a regular EMT connector, screw that in. So this will be on the inside of the house, this will be on the outside of the house. And I'll have rain type fittings that go into here, more EMT going down to the disconnect where another rain type fitting will fit on that disconnect. The reason I'm doing this is because all this right here is rain tight. And it needs to be because it's going to be outside and expose the elements. Also, because of the way my ceiling works, I have to do a little bit of an offset to get it down to where it can get below the framing and go actually make it through the wall and outside. So this was the easiest thing to do. I can drill a hole, send this through from the outside, and then connect the EMT on the inside of the house. Because of the way I ran the EMT in here when I installed my sub panel and upgraded all the lighting and electrical in here, I've got to jump over a few conduit runs already on the ceiling. It was bad planning on my part, but I thought most of the stuff I was going to be adding to the shop was going to be this way rather than, you know, back and this way. So that's going to be a little bit tricky with the bending. All right, let's do some electrical.
If you're new to bending EMT, I really recommend downloading this app. It's called QuickBend and it's available for iPhone and Android. You provide the various inputs for the bend you need to make, and then the app tells you how far to space your bends and how much the conduit will shrink due to those bends. I'm not going to get very detailed into bending EMT conduit. There's a ton of channels out there that have a lot of information on how to do this stuff. One of the channels I used and referenced frequently when I was doing my sub panel installation in my garage was Sparky channel. I'll have a link for that channel down in the description. It's a great channel. It's got a ton of information on all kinds of different electrical stuff. The EMT that I'm running across the ceiling is going to be in 2 pieces, and once I got one half of it done, I wanted to go ahead and connect it to the panel, so I shut off the power and removed a knockout and went ahead and screwed in one of the EMT connectors. And then once I got the connector in there, turned the power back on, and I could work for a while. I turn power off anytime opening up that panel. Some people don't. To each their own. I'm not super familiar with electrical. I've done a little bit of it, but you know, better safe than sorry. Once I got the connector in the panel, I could go ahead and attach the EMT to the ceiling to get it placed, and then I could run the other half from the other direction. Before I could install the other half of the EMT on the ceiling, I needed to go ahead and make the penetration through the wall that would accept the galvanized nipple that would lead down to the disconnect box. I started out by drilling all the way through the wall with a long 1/4 inch drill bit, and then I used a 7/8 inch hole saw on each side of the wall to finish the hole. I then fed the L and galvanized nipple assembly through the wall in preparation of running the conduit down into this disconnect box. As far as I know, all HVAC units need a disconnect box within sight of the unit. This prevents a situation where someone would shut off the circuit at the panel and then the HVAC tech would go out, work on the unit, and then not knowing that someone was working on that unit, someone else would go and turn power back on. This ensures that the HVAC tech will always have an eye on the power and prevent it from being turned back on accidentally. The mini split unit that I purchased requires a 20 amp circuit, so this is a 30 amp disconnect. It has a pull-out switch that will kill power to the disconnect. It also has a spot for 2 fuses. These fuses protect the equipment somehow. I'm not exactly sure how they do it or why exactly that they're there. I just know that they are there and required by some codes. With the disconnect box assembled, I could take it outside, put it where I wanted it on the wall, and mark the conduit so I could cut it to length.
Safety first, kids.
I then used the cutoff wheel on my grinder to cut the EMT to length, and then followed up with a conduit reamer to remove all of the burrs. Using one of these reamers is a necessity so you don't chew up your wire while feeding it through the conduit, and you don't mangle your hands while you're handling the material. Before I could install the EMT back on the outside of the house, I needed to go ahead and finish the run from the sub panel over to the exterior wall. So I threaded on the galvanized coupling and a standard EMT connector, and then measured how far down from the wall I needed to make the offset, and then how long of a piece of EMT I would ultimately need. Once that piece was bent and cut to size, I could connect all 3 pieces together. With everything finished on the inside, I went back outside to attach the piece of conduit I cut earlier to the L and disconnect box, mount the disconnect box, and secure the conduit to the wall. It was now time to permanently mount the inside unit. I flipped the unit on its back and very slowly and gently pulled the copper lines away from the unit and angled slightly downward to match the angle of the hole I drilled earlier. Based on the number of warnings in the manual not to kink these pipes, I came to believe that if I did, the entire world would explode and we'd all die. But seriously, don't kink the pipes in bending them. Once I had the pipes where I wanted them, I used some electrical tape to bundle the line set and then wrapped it all tightly with insulation tape. Fed the signal wire first through the hole that I had drilled, and then lifted the indoor unit into place and down onto the bracket. I then went outside to bend the line set down into position against the line set cover, and after fiddling with this for a little bit, I decided that I would just leave this for the HVAC tech who's going to do the final connections. I now needed to prep the site for the outdoor unit. I placed these on a couple of concrete pavers, and the most important thing here is to just make sure that both of these pavers are perfectly level. I could now go ahead and place the outdoor unit down onto the pavers. I now needed to get power from the panel to the disconnect box, so I started out by removing the cover from one of these L's, and then went inside and took off the cover to the sub panel. With this being such a short run, I decided to just push the wires through by hand. A fish tape here would probably be more trouble than it's worth. Once I had the wires outside and through the L, I looped them around and sent them through the conduit down to the other L, where then I will send it into the disconnect box. This unit requires a 20 amp breaker, and that means I needed to use 12 gauge THHN. Actually, since it's going outdoors, it needs to be THWN, but what I've learned is that nowadays THHN and THWN are usually the same thing. I double checked the wire that I had on hand, and it in fact was THWN as well as THHN. With the wires now inside the disconnect box, I could start making all of the connections. This is pretty straightforward. This is just a 3-wire circuit. It's got 2 hots and a ground. The ground wire goes into the neutral terminal, and each hot goes into line 1 and line 2. I then went back inside to make the connection at the panel. I installed a 20 amp circuit breaker, 2-pole circuit breaker, since this is a 220 volt line. I attached the grounding wire to the grounding bar and attached the red and the black to the breaker. With all the electrical connections complete, I put the cover back on the panel and on the L's. I then needed to make the connection between the disconnect panel and the outdoor unit, so I removed the terminal cover from the outdoor unit and punched out 2 of the knockouts. To make the run from the disconnect box to the outdoor unit, I bought some liquid tight conduit, which comes with compression connectors. I connected one to the disconnect box and then attached the liquid tight and cut it to the length I needed to make the connection to the outdoor unit. I then connected the outdoor unit's terminal cover to the liquid tight in a similar fashion. Like on the indoor unit, I just didn't have a good way to get my camera into a good position to film the wiring connections. The L1, L2, and grounding terminals on the right are for the power from the disconnect box. The 1, 2, 3, and ground terminals on the left are for the signal wire to connect. It is vital that the red, black, and white wires from the indoor unit connect to the same terminals on the outdoor unit. A couple things to note here. One, make sure when you are connecting the signal wire that you've run it through the terminal cover first, or else you'll have to take it off and run it back through and reconnect it. Second, I had shown earlier that I connected the liquid tight to the terminal cover, and what I actually did is I ended up taking it off and doing all the connections on the outdoor unit and then feeding it through the terminal cover, through the liquid tight, connecting the liquid tight, and then running it all the way up into the disconnect box. I can now make the connection at the disconnect box. This is really simple, very similar to connecting the line to the disconnect box. The ground goes into the grounding bar, and then the red and the black go into each side below where the fuses connect. Once the wiring was complete, my part on this project was pretty much done. I hired an HVAC technician to come out and do the final connections, pressure test, and vacuum the unit. While he was doing the vacuuming, I sealed up the wall penetrations with some clear Flex Seal and attached the line set covers.
Alright, that is a wrap on this project. It was an easy project, but I wouldn't say it was straightforward. There were many times where I had to take breaks to get on the internet, research something, figure out, make sure that I was doing it correctly. It probably took me different parts of about 3 or 4 days to install this. But I filmed the entire thing, everything that I did, and the footage in the end was only about 4 hours long, I think, maybe a little bit less than that. So that just tells you how much I was stopping to do research and figure out some issues that I was having and make sure I did them all correctly. And remember, in the description down below, I have a link to the install article, which again walks through the research that I did. It talks about my specific situation and why I ultimately ended up on a ductless mini split, as well as this specific Pioneer unit. And I'll also give my early impressions after a week or so of using this Pioneer mini split. If you like this video, please give it a thumbs up and leave a comment down in the comments section. Let me know what you thought. If you didn't like this video, I don't know what to tell you. I'll try harder next time. If you want to see more videos like this, click the red subscribe button down below and ring that little bell so you get notified every time I release a new video. And if you just gotta have more of the average craftsman, check me out on social media. You can find me on Facebook, Twitter, and Instagram. Thanks for watching. I'll see you next time.